Exam number 1 prep. Let's start with the instruction. The exam will be administered through Canvas under the quizzes section. Students are required to use the Respondus Lockdown browser with a front-facing camera enabled during the exam. Please note, Chromebook OS is not recommended for this setup. You do not need to bring a calculator. Lockdown browser has one built in. The exam is open notes and allows use of a physical textbook. However, a digital ebook is not permitted. Headphones of any kind, including AirPods, are not allowed during the exam. The exam consists of 35 questions, including 30 multiple choice and 5 short answer questions, with a total score of 100 points. You will have 2 hours to complete the exam. Students will be allowed 2 attempts to answer each question correctly. The exam opens on Friday, June 20th at 12 p.m. PST and must be completed by Saturday, June 21st at 12 p.m. PST. We begin with Chapter 1, which sets the foundation for macroeconomics, the study of the economy as a whole. In this chapter, we focus on the big picture topics such as growth in national income over time, changes in the general price level, inflation or deflation, and the unemployment rate in the labor market. We introduce one of the most basic models in economics, demand and supply. The key concept here is equilibrium, which occurs when the quantity demanded equals the quantity supplied. We also discuss the distinction between 2 important types of variables: endogenous variables determined within the model, exogenous variables determined outside the model. In addition, we differentiate between flexible prices and sticky prices. In the long run, prices are flexible and adjust to ensure that markets clear. In the short run, many prices are sticky and adjust slowly in response to changes in demand and supply. Finally, we briefly compare macroeconomics to microeconomics, which studies individual decisions. A household chooses consumption C and leisure L to maximize utility, subject to their budget constraint, whereas a firm chooses input levels to maximize profit, subject to their resource constraint. In Chapter 2, we study how to measure a country's economic output, primarily through gross domestic product, GDP. There are 3 main approaches. 1. Production or output approach. GDP is measured by the value of final goods and services produced, summing the value added at each production stage. Value added avoids double counting intermediate goods. 2. Expenditure approach. GDP is calculated as the total spending on the economy's output. Y equals C consumption plus I investment plus G government purchases plus NX net exports, where net exports equals exports minus imports. 3. Income approach. GDP represents the total income earned by households and businesses in the economy, which includes wages, rents, profits, and taxes, minus subsidies. I recommend reviewing the formula we covered in a lecture along with the components listed in this study guide to reinforce your understanding. Real versus nominal GDP. Real GDP uses constant base year prices, and nominal GDP uses current prices. By knowing real GDP and nominal GDP, you can calculate the GDP deflator, which serves as a measure of the price level. By using the GDP deflators, you can calculate the inflation rate as the percentage change in a GDP deflator between 2 periods. Growth formulas. Percentage change of a product, for example, percentage change in P times Y equals percentage change in P plus percentage change in Y. And percentage change of a ratio, for example, percentage change in Y over L equals percentage change in Y minus percentage change in L. Next, consider the Consumer Price Index, CPI. Remember that the CPI is a fixed weight price index used to measure the cost of living. Lastly, the labor market matrix. We start with the formula for the unemployment rate. This tells us what fraction of the labor force is currently without a job but actively seeking work. Next, we define the labor force itself. This simply includes everyone who is either employed or unemployed. Finally, we calculate the labor force participation rate, which tells us what portion of the adult population is either working or actively looking for work. In Chapter 3, we explore how national income is determined in a closed economy with fixed supplies of capital K and labor L. Production function, that is Y equals a function of K and L. This function shows the maximum output the economy can produce given K and L. Returns to scale. If inputs are scaled by Z, then constant returns to scale means Y2 equals Z Y1. Increasing returns to scale means Y2 is greater than Z Y1, and decreasing returns to scale means Y2 is less than Z Y1. Factor prices. Real wage equals W over P, and real rental rate equals R over P. Demand for labor. Marginal product of labor, MPL, equals real wage, W over P, or MPL equals DF over DL, also equals delta Y over delta L. Demand for capital. Marginal product of capital, MPK, equals real rental rate, R over P, or MPK equals DF over DK, also equals delta Y over delta K. Lastly, Cobb-Douglas production function, that is Y equals A, K, take the exponent alpha, L, take the exponent 1 minus alpha. Capital income equals alpha times Y, and labor income equals 1 minus alpha overall times Y. And PK equals alpha times Y over K, and MPL equals 1 minus alpha overall times Y over L. In Chapter 4, we're focusing on the components of aggregate demand and how they interact with the supply side of the economy. Aggregate demand consists of 4 parts: consumption C, investment I, government expenditures G, and net exports NX. In a closed economy, we ignore NX. Consumption depends on disposable income. The marginal propensity to consume, and PC tell us how much consumption changes when disposable income changes by $1. Investment is a function of the real interest rate R. As R increases, investment decreases because borrowing becomes more expensive. The economy is in equilibrium when output equals demand. Y bar equals consumption, a function of Y bar, minus T bar plus investment, a function of R plus G bar. Output Y bar is fixed by the production function and available inputs. Y bar equals a function of K bar and L bar. The real interest rate R adjusts to equate demand with supply. National saving S is the sum of private and public saving. S can be equal to Y minus C minus G. Since investment equals saving in equilibrium, S bar equals investment, a function of R. The real interest rate R adjusts to ensure that this condition holds. Budget conditions. If T is greater than G, government runs a budget surplus. If T is less than G, government runs a budget deficit. And if T equals G, the budget is balanced. After all, the real interest rate R equilibrates both the goods market and the loan bond funds market simultaneously. Here, I'd like you to pause and try the sample practice questions. Question number 1. This question asks about assumptions used in macroeconomic modeling. In the short run, prices are often assumed to be sticky. They do not adjust immediately. In contrast, in the long run, prices are assumed to be flexible, adjusting to clear markets. The correct answer is D, sticky prices and flexible prices. Question number 2. This question focuses on GDP measurement. Only the market value of final goods is counted. The grower sold $4,000 in raw cherries and $30,000 in jam, a final good. However, the value of the jam already includes the value of cherries used, so we should not double count. The donation is excluded since it is non-market. The correct GDP contribution is $4,000 of raw cherries plus $30,000 of jam equals $34,000. The correct answer is C, $34,000. Question number 3. Follow the formula we discussed, which applies the growth rate of a ratio. To calculate real GDP growth, subtract the inflation rate, that is, the growth of the GDP deflator, from nominal GDP growth. Thus, real GDP growth equals 5% minus 3% equals 2%. The correct answer is A. Real GDP increased by 2%. Question number 4. This question applies the Cobb-Douglas production function. Given y equals a, k takes the exponent alpha, l take the exponent 1 minus alpha. With alpha equals 0.3, then labor's share is 1 minus 0.3 equals 0.7. Following the derivation I wrote down, a 10% increase in labor leads to approximately a 7% increase in output. So the correct answer is B. Output increases by about 7%. Question number 5. Given the consumption function C equals 1000 plus 0.25 times y minus t, and the tax function t equals 20 plus 0.25 times y, and y equals 10,000. First, compute t. So t equals 20 plus 0.25 times 10,000 equals 2,520. Then plug into the consumption function. So C equals 1,000 plus 0.25 times 10,000 minus 2,520 equals 2,870. So the correct answer is D, 2,870. Question number 6. We are given demand and supply equations for coffee. Given PT equals $1 and PE equals 50 cents. So we simplify QD to become 27 minus 2PC and QS to become negative 0.5 plus 3PC. To find the equilibrium, we set QD equals QS, so 27 minus 2PC equals negative 0.5 plus 3PC. Then we solve for PC, that is also equal P star at $5.50. Then we use P star to find Q star by substituting into either the demand or supply equation. This gives Q star equals 16. The equivalent price and quantity P star equals $5.50 and Q star equals 16. The endogenous variables are PC, QD, and QS, and the exogenous variables are PT and PE. Question number 7. To calculate nominal GDP, we multiply the current year price by the current year quantity for each good and sum across goods A and B. And to calculate real GDP, we multiply the base year price by the current year quantity for each good and sum across goods A and B. Finally, the GDP deflator is calculated as nominal GDP over real GDP times 100. By following the steps, you will arrive at the same answers I have here. Question number 8. Given the information provided, we can compute the following. Adult population equals 0.7 times 10 million equals 7 million. Labor force equals 1 minus 0.2 overall times 7 million equals 5.6 million. Number of employee equals 0.6 times 5.6 million equals 3.36 million. And number of unemployed equals 5.6 million minus 3.36 million equals 2.24 million. To compute labor force participation rate, we divide labor force by adult population. So we take 5.6 million divided by 7 million times 100% equals 80%. And the unemployment rate, we divide number of unemployed by labor force. So we take 2.24 million divided by 5.6 million times 100% equals 40%. Question number 9. Knowing the production function and the values of L equals 400 and K equals 400, we can compute Y equals 8,000. After doubling both inputs, L equals 800 and K equals 800, then Y becomes 16,000. As such, we can conclude that as L and K are double, Y is also double. Thus, this production function exhibits constant returns to scale. Question number 10. Given the information provided, we first compute the value of consumption, C equals 3,900. Then, using the National Income Accounting Identity, Y equals C plus I plus G, we solve for R equals 4%. Finally, we use the value of R to compute investment I equals 1,600. Then to compute private saving, we take Y minus T minus C equals 1,600. Public saving, we take T minus G equals 0. And national saving, we add private saving and public saving equals 1,600.